Okay, we're in section 54. Again, it's the contents that you read through, make some attempt to understand it, examples, and then exercises. My name is Ron Bannon. This is a draft version of my adaptation of Webster Wells' Advanced Course in Algebra, dating back to 1904. Webster Wells was a professor at MIT. He wrote a ton of books that were designed to prepare students to enter into university-level mathematics courses for the STEM-related careers. This document, the PDF form anyway, is being made available to the prison mathematics project participants only. This will be published at a later date. In the meantime, though, if you want to reach out to me, my name is Bannon. My email address is also Bannon. That's B as in boy, the @ symbol, NNON.US. All right? So if you're reading this section over here, again, Wells, you might read it and say, I'm not sure where he's going with this. And that's true with most of people's education. They don't know where they're going, all right? So you want to go forward, of course, in your educations, and hopefully you take some side roads here and there. But the bottom line is he's talking still about quadratic equations. He's talking about factoring. He's talking about the quadratic formula. And you read through that, try to make sense out of it, all right? He certainly the examples here, he does the examples. I'm also going to do the same examples, by the way. So I'll go through this one over here, and we're going to do one problem at a time. And again, the goal here is that you start to read his sections, and then if you need help with the examples, you watch me. But you want to be able to get to the exercise at some point. And part of that is just getting through the material. All right, so what I'm going to do over here, I'm going to start doing the problem. Now, certainly, if someone says factor this, I don't think I'd give it much thought. I would just simply say, oh, gee, I could factor that just by using what's called trial and error. And I'd probably say maybe 3x and 2x. And if I said, 3x and 2x, I'll be honest with you, the 3 couldn't go here because it would be a factor in the problem. And it's not a factor here, all right? So I'm going to say it's 3 over here, 1 there. I'm going to get some signs going here. I'm going to look at it, and I'll try. Whatever I say, I'll try. And what do you get? 3 times 6x squared plus 9x minus 2x minus 3. And that would give me 6x squared plus 7x minus 3. So that's the factorization of it. But I got to be honest with you, a lot of times I can't do that. So what we do is we use the quadratic formula instead to factor it. Let me go through that with you. And this might seem strange to you, but you could take this equation and use the quadratic formula. I'm going to get my eraser out, and I want to go to the, sort of like something new here. So let me do this. And give me a second. Get my eraser out. I'm going to erase all this stuff over here because it's not what I want to show you. Right? I want to go through what Wells would be doing here. And this is important now. And the reason it's important is a lot of times you can't factor with your fingers, but you can still factor the problem knowing the quadratic formula. So I'm going to write this down, and I'll be careful. And x is, I'll be very careful here. So it's going to be, the bottom's going to be twice the a, that's going to be 12. Then the top's going to be minus b, that's going to be minus 7, plus or minus. And let's take a look at that. What would you get? You get, let's see, the b squared is 49, minus 4, times a, times the c, which is minus 3. So I'm going to put a 3 here, but I'm going to change the sign. Let's see what you get. X equals minus 7 plus or minus, and I'll put a 12 in the bottom. It's 49. And what do you get there? Let's take a look at that. That's pretty complicated, isn't it? 4 times 6 is 24. 24 times 3 is going to be 60 and 12, 72. 72 and 9, 81, 121. I'm getting tired. X equals minus 7 plus or minus. You should realize it's taking tremendous more effort than me doing the trial and error business. It's going to be 11 over 12. So what do you get over here? X equals minus 7 plus 11, which is going to be 4 twelfths, or make sure I did that right. Minus 7 plus 11, 4 twelfths, or minus 18 twelfths. Well, this is going to be what? 1/3 or Let's see what we get there. That's going to be what? Minus 2/3. So some people say, oh, I can factor this now, and they put this down. They put down x minus 1/3. I'll tell you why they do that. They know it's a root. And x minus 1/3 minus 1/3 is 0. And what's the other guy going to be? X plus 2/3. But that can't be right. Right? That can't be right. So the question is, what would you do there? I guess you'd have to, probably multiply this thing by, let's see if I did that right. 6 goes into that. Oh, I'm sorry. I see my error now. I'm daydreaming again. Let me put that down again for you. So 6 goes into 18 minus 3 times and 2. So minus 3 over 2. I'm sorry about that. I don't know why I did that. That would be x plus 3/2. But that is not the factorization of that. There's no way that's true. So I'm going to just, look at it. I realize everything's integer. So I'm going to say maybe a 6 in front. Someone says, why 6? I'm trying to get rid of those fractions. And what would you get? I'm going to say it's 3 times x minus 1/3, and it's 2 times x plus 3 over 2. And what do you get there? You get 3x minus 1 times 2x plus 3. Now, I hope you recall we just did that with trial and error. We got it. It wasn't a problem. All right? So someone's going to say, why would I go the quadratic formula? Well, on certain occasions, you won't be able to do it otherwise. All right? So what I want to do is I want to look at this problem number 2. And again, I would not go near the quadratic formula for this over here. I'm going to look at it. I don't know. I got to try something, right? So I'm going to say maybe 4 and 1. That definitely gives me that. All right? And then I'm looking at that 12. And I'm going to say 3 and 4. But if I say 3 and 4, I can't put the 4 with the 4. So I'll put 3x here, and I'll put 4x over here. And again, I'm not saying this is correct. I got to try it. I'm going to say plus and minus. Let me see if that works. And if it doesn't, I'll erase it. 4 times 1 is 4. You get 16 minus 3. 16 minus 3 is, that worked, 13. And you get minus 12x squared. All right, now if I use the quadratic formula on this, right, you see this over here? Use quadratic formula. A little bit tough. I'll write this down for you. This is the C, this is the B, and this is the A. Oh, well, let's see. Twice the A would be minus 24. The opposite of B is minus 13, plus or minus. I always find it very tedious quadratic formula. Well, let's see. B squared is 169. Minus 4 times A times C. Oh, that's work for me. I'll write this down. 4 times A is minus 48. Well, let's put a plus over here then. So it's going to be 4 times 12, 4AC, right? So it's 16 times 12. That's 160. And that's because 10 times 16 is 160. And then 32, right? So 192. Again, I find it very tedious. I really do. I find that just almost ridiculous to even do this if I can do it what I did over here. So what do you get? Minus 24, but there's a point to it. You need to learn this. Minus 13, plus or minus, what do you get over there? 169 and 192. Let's see, that's 11, right? 7, 16, 361. Wow, that's a tough one, huh? Let's take a look. I realize not everyone's really good with numbers, and I'm not good with numbers either. 19 times 19. Let's see what you get there. 9 times 9 is 81. Let's see, 9 and 8, 17. And you get 190 now. That's not so bad. 1, 6, 361. I got it. X equals minus 13 plus or minus 19 over minus 24. And again, I find this incredibly tedious. What do you get over here? Well, let's write it down. Well, you get minus 13 plus 19, which is going to be 6 over minus 24. Let me get my eraser out. Or, what's the other one going to be? Minus 13 minus 19. That's minus 32, right? Minus 24. I got to reduce this. This is going to be minus 6. 6 goes into 6 once. Goes into 24 4 times. Or, well, that's 8 then, right? So it's going to be 4 thirds. So I'd write it down. What do I write down? X minus 1/4. And then it's going to be x minus 4 thirds. I'm sorry, x plus 1/4, x minus 4 thirds. I'll explain that again to you. That would produce a 0 there, because minus 1/4 plus 1/4 is 0, and the 4 thirds would produce 0 over there. What am I going to do? I'm going to multiply by the LCD now, and I'm hoping to get it. All right, so what do you get? Well, I'm going to say 4 times x plus 1/4. And then, what would I get there? 12, it would be 3, right? 3 times x minus 4 thirds. And what does that give me? Let's write this over here. This gives me 4x plus 1. I'm associating this. If you associate this, what do you get? 3x minus 4. Am I getting the same thing? Someone's going to say, no, you didn't get the same thing. And let's take a look at that, see what happened. All right? And something went wrong somewhere. Did I make a mistake here? Yeah, it's not the right one, is it? So someone said, what went wrong with this? I'm not getting that. This is what makes this so tricky. I'm going to try this instead. All right, let me erase. Let me erase. Let me try again. And what do you get? Well, I got to write this down. And I'm going to say 4 times x plus 1/4. And I'm going to say minus 3 times x minus 4 thirds. Let's see what we get. I'll put this over here. You're going to get 4x plus 1. And what do you get for the next guy? You would get minus 3x. By the way, I'm associating these two and these two. You get minus 3x plus, 4. Let me make sure that okay. Let me write this down. 4x plus 1, 4 minus 3x. Let me write the first factor a little bit different. 1 plus 4x, it's commutative. What's the other guy going to be? 4 minus 3x. Am I getting it? I'm getting it. All right? It's tricky, though. By the way, when I say it's tricky, it is not tricky by trial and error. It's tricky using the quadratic formula. All right? All right, let's do the next one. The next one says factor it. And, certainly I'm looking at it, and someone says, what are you going to do with that to factor that guy? And certainly, I guess I got to get a quadratic in this, right? So I got to make a decision. I'm going to go with the x squareds. All right, I'm going to write this down. So I want to point out what I'm looking for. I'm looking for ax squared plus bx plus c. That's what I'm looking for. So let's write this down. I definitely see the 2, x squared. I'm going to outline that for you. Right, now what I'm going to do, I'm going to go any term with an x in it. So I'm going to say this one here and this one over here. And I'm going to write that down now. Now what's that going to be? Plus minus 3y, that's this guy over here, plus, I'm sorry, that's not plus, minus 7x. Now, as I do this, I want to make sure you know I got minus 3xy and minus 7x. Now, I'm going to say plus the constant terms. I want to say the constant terms, the terms that don't have an x in it. This one, and this one. Let me write that down for you. And that's going to be minus 2y squared, all right, plus 4y, plus 6. And I got to factor it. Now, someone can say, how would you factor? I don't think trial and error is going to work. I think it's just too much work. So what I'm going to do I'm going to use quadratic formula. And it's going to be work too. I'm not saying it's not. So let's write this down. A is 2. B is minus 3y minus 7. And the C is going to be, well, I'm going to write it a little bit differently. I'm going to write it as 6 plus 4y minus 2y squared. So I can use quadratic formula. Right? I have to do it. I have no other choice. I don't think I could do it otherwise. Not by trial and error. Not me, anyway. Let's take a look. The root x would equal, let's see, what goes in the bottom? Twice the a, which would be 4. Now I get to the top. It's the opposite of b, so that's 3y plus 7. Plus or minus, here comes the tough part. It's so tough, I'm going to write it on the side. So it's going to be b squared minus 4 times a times c. Well, b squared is not that bad. It's going to be, I'll write that down for you. So b squared is going to be, well, what do you get? You would get minus 1 squared, 3y plus 7 squared. What does that give you? Well, I got to be careful here, right? So minus 1 squared is 1, so you get 9y squared plus 49. And let's see, you get 2142y. All right, that's done. Let me erase this over here because I need some more room. Now what I got to do? I got to do 4. Well, actually, I'm going to write it all down. I'm going to write minus 4 times the a. Well, the a is 2. That's easy. And what's the c? Oh, it's going to be a nightmare. 6 plus 4y minus 2y squared. Well, let me write that down now. What's going to be, well, minus 4 times minus 2, I'm sorry, minus 4 times 2 is minus 8. That's going to be minus 8 times 6 is minus 48, right? And minus 8 times 4 is minus 32y. And minus 8 times minus 2 is plus 16. And yeah, it's work. There's no doubt about it. Let me see if I can get things to come together. So I'm seeing 9y squared, 16y squared. That's 25, isn't it? And let me do the y's now. And 42 minus 32 is 10y. 49 minus 48 is plus 1. I hope that's not too difficult. Oh boy, I'm not even halfway done. Let's keep going. 4, 3y plus 7, plus or minus. Let's see if I could do that. I think I can. I'll write this down for you. It looks like a perfect square to me. 5y plus 1 squared. Now, by the way, Wells is big on these tricky things, but I'm going to write this down for you. All right, let's put this down. So it's going to be x equals 3y plus 7 plus or minus. Now, by the way, in reality, it's really this over here, the absolute value of 5y plus 1 over 4. All right? Let's keep going. And let's take a look. See if I can write it down. I want to try to get something out of it. And let's just make a stab at it. All right, I'll write this over here. X equals 3y plus 7. Let's just assume 5 plus y is a positive. Let's see what happens. What are you going to get? Plus 5y plus 1 over 4. And you're going to get x equals 3y plus 7 minus 5y minus 1 over 4. Well, I got some work to do, don't I? Let's see if we can do that. And what are you going to get? x equals, I'm doing this one first, that's 8y plus 8, wow, that was convenient, over 4. And what's the other one going to be? Whatever we get, we're going to check, by the way. Again, I'm making assumptions about 5y plus 1 being positive. If we're negative, I have another problem to worry about, but let's just do 1 at a time, see what we're getting. 3y minus 5y is minus 2y, right? And 7 minus 1 is going to be plus 6. And that's all over 4. Well, this one's convenient. This one turns out to be 2y plus 2. And this one is not so bad. This one's going to be, let's see, I'm going to divide by 2. So I'm going to say 3 minus y over 2. So someone said, I have no idea where this is going. It's going back to a factorization of the problem. So I'm going to put this down now. I'm going to put down, well, we just solve for x, right? So it's going to be, let's write this down. X minus this root. Again, we're going to check. And then it's going to be x minus this root. And what's that going to be? 3 minus y over 2. Now, I got to be honest with you, that's not going to work. I'll tell you why it's not going to work. I'm not getting a coefficient of 2, right? So I'm going to write it down. I can put the 2 in here. So let's do that and see what we come up with. And I'm going to take this 2 and going to associate it with the second factor. Let's write this down now. So what are you going to get? X minus 2y minus 2. Then you can get 2x minus 3 plus y. There's a factorization for you. But, oh, I shouldn't have boxed it. I really have to back up. That's really crazy to box that guy. Okay. Check it. You got to check. Check. How do you check it? Multiply it out. I understand people get tired, though, and what I want to do is just look at the key. X minus 2y minus 2, 2x plus y minus 3. But I do want to go through the check. I want to see if you know what? We'll go to the next problem. You can check that if you want, though. Check it out. Let me go to the next question. Factor it. Oh, boy, this looks like a tough one. So, trial and error is going to work. I'm going to try it. 3x and x. Again, I would never go anywhere near the quadratic formula or anything else for that matter if I could do things by my hand. I'm going to say 4 and 1 and minus plus. Does that work? 3x, 9x squared, minus 12 plus 3 is minus 9. Works beautifully. All right, I do see the answer over here. I do want to walk you through the work, though. It says the coefficient of x squared is a perfect square, so maybe use completing the square. Certainly completing the square is not a bad idea. For a lot of students, it's difficult, but you could complete the square on it. So I did use completing the square over here. All right, you can do that if you want. There are many ways to do it. I want to point out I'll do it a little differently in the completing the square department. I'll write this over here. This would be x squared minus x, and then I'd have a minus 4 over here. Again, I'm just taking this and rewriting it to complete the square. What do? Half of this guy's coefficient, and you square it. What's that going to be? That would be plus, let's see, half of minus 1 is minus 1. You get a quarter. Now, of course, if I do that, I'm really adding 9 quarters. That means I got to subtract 9 quarters. And again, I find this to be tedious as well. Just like going to quadratic formula, just crazy. What do you get up here? 9x minus 1/2 quantity squared. And then if I did this over, it's minus 9 quarters, minus 16 quarters, which is minus 25 quarters. All right? And over there, what you get, it's a perfect square problem. And someone says, what do you mean by that? I'm seeing it. I'll write it down for you. It's actually 3x minus 1/2, this whole thing squared, minus 5/2 squared. It's a difference of perfect squares. So what are you going to get over here? You can get 3x minus 1/2 plus 5/2 times 3 times x minus 1/2 minus 5/2. You get the same result, by the way. Let me go through that with you. What are you going to get over here? And again, I really can't say that. I think using your fingers is probably the best way to go. This is going to be 3x minus 3s plus 5 halves, which is going to be plus 1. Let me make sure I did that right. Minus 3s plus 5 halves is 2s. Yes, 1. The next one's going to be 3x. And then you get minus 3 halves minus 5 minus 8 halves, which is minus 4. Do we get the same result? Of course we do. You could have also used the quadratic formula to find the roots and then played around with it until you got the correct factorizations. Again, I can't say it enough times. I don't think I would be going anywhere near the quadratic formula unless I had to. Now here's an example of a problem I can't factor using my finger numbers. So what I'm going to attempt to do is complete the square. All right, I'll write that down for you. As I do with my claim over here, it might be really difficult to do. Let me write this down for you. So I'm going to put down 3, and I'm going to write this over a little differently, by the way. I'm going to write it as minus, and I'm going to write down 4. Oh, you know what? I'm going to factor out 4. Put that down for you. So 4 times x squared minus, let's see if we can do that. And what would you get over there? That would be 3x, right? I know it's tough, by the way. You could use quadratic formula too. Don't worry about that. Quadratic formula will lead to this as well. Don't worry about that. You can do that too, if you want. And let me take a look at that. Let me see if I did it right. 3, that's minus 4x squared. Oh, nope, I did it wrong. That's plus. Half of 3 is 3 halves. Square it, you get 9 quarters. Let's keep writing it. What do you get over here? 3 minus 4. Oops, I forgot to do something, which I'm always telling my students, never forget this. All right, I just forgot it, though. And I'm going to say, what am I doing? I'm subtracting 9. I have to add 9 now. Let me make sure I did this right. So see if it's true. You get 3 minus 4x squared minus 12x. Minus 4 times 9 quarters is minus 9, and minus 9 plus 9 is 0. This looks good. I got to write this over again, though. 3 plus 9 is 12 minus 4 times a perfect square. That perfect square is going to be x plus 3 halves squared. I got to write this down a little differently. So I'm going to write it as, let's see what we're going to write it down as. I want perfect squares, right? So root 12 squared, I'll write that down. We'll do that later. Minus 2x plus 3 halves squared. Oh, let's write this down. So what do you get? Root 12 minus 2x plus 3 halves times root 12 plus 2 times x plus 3 halves. Let's put this down. What are you going to get over here? I'll write this down. Root of 12 is actually 2 root 3's. This is going to be minus 2x. Let's see, minus 3, right? And what's this going to be? It's going to be 2 root 3's plus 2x. And 2 times 3 halves is going to be plus 3. Again, I'm not going to multiply it. I just want to point out you get this over here. Let me see if that's true. Yep, got the first guy. Yep, got the second guy. Things are working out pretty good. All right. Okay, 6 I can't factor. I got to be honest with you. Completing square is going to be easy on this guy over here. So let's put it down. So it's going to be x squared minus 4x. Half of minus 4 is going to be minus 2 squared. You get plus 4. Minus 4 plus 9. What do you get over here? X minus 2 squared. And minus 4 plus 9 is plus 5, right? Well, that looks kind of crazy looking, doesn't it? So I got to write this down now as a difference. That's going to be x minus 2 squared minus a minus 5. Well, I still got to write it as a square. What do you get over here? X minus 2 squared minus, well, what square would give you minus 5? Well, that's not so bad. It's going to be I root 5 squared. Because when I square the I get I squared, which is minus 1. Yeah, it works pretty good. So let's write this down. What do you get? X minus 2 minus I root 5 and x minus 2 plus I root 5. All right? Again, these things are written over here. Again, if you find completed square difficult, you can certainly use quadratic formula. Let me just briefly go through that with you. X equals, let's see, the opposite of b, which is 4, plus or minus the b squared, which is 16, minus 4 times a times c. Well, that's going to be 36, right? And what do you get on bottom? Twice the a, which is 2. Let's do this together. 4 plus or minus 16 minus 36 is going to be, let's see, minus 20, right? Over 2, x equals 4 plus or minus, well, that's going to be 4i. I'm sorry, the root of 4 is 2, so 2i root 5 over 2, divide through by 2, you get 2 plus or minus I root 5. What do? Let's write it down. It's going to be x minus 1 root at a time, minus 2 plus I root 5. The other one's going to be x minus 2 minus I root 5. We get the same result. Okay, let's talk about what you have to do now. I know it's a tough section, by the way. What I mean by that, if you can factor using your fingers, please do so. All right, that's what I'm mostly doing. If you need to use quadratic formula, like on something like this, please do so. All right, if you want to complete a square, please do so. The point is to factor, and factoring can be very tedious. I do like using my fingers, but a lot of times I can't. So you have 3 different techniques: trial and error with your finger numbers, quadratic formula works on quadratics, and then you got this completing a square thing, which we've done before. All right, so there's going to be problem sets. You do the exercises. Yeah, some are easy, some are more difficult. Like number 1's easy, number 2's easy, number 3 is easy, number 4 is also easy, number 5, easy, by finger numbers I mean. But you may want to practice using quadratic formula or completing a square, whatever you want to do. Number 6 is easy. You can use quadratic formula, completing a square, whatever you find convenient. I just like using my finger numbers. They're really easy. 7's easy. 8's easy. 9 is easy. 10's easy. Are they all easy? 11's easy. 12 is easy. 13 might be a challenge for you, but it's not that. It's still finger numbers. 14, easy. 15's easy. My God, everyone's easy. By the way, when I say that, don't be intimidated. Easy, easy, easy. All right, this one might be a challenge for you. We've done something similar like that. I use quadratic formula to do it. This one might be a challenge for you. We use quadratic formula to do that. Remember that. And certainly I would stick to that as well. Let's see, 21, probably quadratic formula again. Quadratic formula again. Yeah, they're getting difficult, aren't they? Quadratic formula. They got some confidence builders. And again, I would recommend those confidence builders with your fingers, but also to do, either completing a square or the quadratic formula, just to make sure you understand what the technique is. All right, completing a square, make sure what that means. Completing the square, completing the square. And again, there's a lot of practice. We do recommend you practice. And I kid you not about that. We recommend that you practice these problems over here. Let's see, there's 34 problems. Then when you get to the SAGE code, what's SAGE? Computer algebra system, or a CAS. It's open source software, which means it's free. I want to say it's free. It's kind of like a joke it's free. People are working really hard to make it happen. And certainly if you're going to be promoted by that community, work hard to promote it and work hard to, if you have the capabilities, to improve the software. Again, you can download the software or use the interactive web-based application and try this stuff. See if you can do it. All right? Do I make mistakes? How many times I got to say this to you? 1 billion times. I make mistakes all the time. If you find any errors, though, please reach out to me. My name is Bannon. My email address is b as in boy, the @ symbol, nnon.us. We love hearing from students, by the way, and teachers too, by the way. We love hearing from people. All right? So we'll plow forward, but for the most part, one section at a time. It takes time and effort. I spent years working on this document, and what I mean by that, I had to do a lot of research, a lot of forensics with the text and stuff, looking around, certainly analyzing things, typing things up. It took me a lot of time, by the way. It's going to take you time too. That's what's important. It's going to take you time. Thank you for paying attention.